right. Hi there, friends. Life is filled with uncertain events, and often we must consider the possible outcomes or look at possible outcomes before we even decide and make a decision about something. So we ask ourselves questions like, what is the chance of success for such and such decision, and what is the chance of failure for such and such decision? So is it something worth making a decision for or not? So that is where the concept of probability comes to play, where we use statistics and probability practices to actually determine the likelihood of an event and for either success or failure or ups and downs or any probability context that we are actually looking for, then that we can use statistics to make determination that could be close to it can be close to a good prediction. So to give an example of probabilities used in the actual field of work, CEOs need to make, for example, huge decisions when they invest, let's say, in their research or in their development programs, or contemplating buyouts or that kind of stuff. But by using probability and the statistical data, they can actually predict how likely the outcome of each of those decisions are going to be, based on which they make the right call for that specific topic. So some of you might be wondering, okay, then how does probability really apply in the real life example? So essentially, probability is a chance of, again, something happening versus all of the chances that are available. So in other words, or a more academic definition that I kind of live with, is that probability is the likelihood of an event happening. That's it. Probability of an event happening versus, you can add by, versus all of the events possible. So the word event has a specific meaning in the context of probability when we talk about probability. So simply put, an event is like a specific outcome or a combination of several outcomes, and these outcomes can be pretty much anything. Getting heads, for example, if you're flipping a coin, you're flipping a coin, getting heads or tails. That's the type of probability. If you're rolling let's say, for example, a die, let's say six-sided die, that's a probability. Or let's say if you're running, if you're competing on something, anything that we can analyzed for probability is actually can actually be a subject of probability. So taking flipping the coin example, for the example of this case, as you know, there is no one single-sided coin, so coins are always two-sided, right? So there's two possible outcomes if we flip a coin, of either getting head or getting tails. That means we have two possible events each time that we flip the coin. So, and we need to assign probabilities to each one of them. So when dealing with the uncertain events, we are often satisfied by simply knowing whether an event is likely to happen or it's unlikely to happen. I you know this is one of the methods that we actually express probability to say something is likely to happen or unlikely to happen. We may add some adverb to it and say more likely to happen or less likely to happen, but that's not a correct way to express probabilities of an event. Ideally, we want to be able to measure and compare the probabilities. In other words, we want to be able to quantify our probabilities and in relation to likelihood, other probabilities. And so to be able to do so, we should express probabilities numerically, right? So even though we can express probabilities there are several ways that we can express probabilities. It could be percentages or fractions, but conventionally we use zeros and ones. And let me just see. If this line was, let's say, this line was the line of probability where we have 0 here and 1 here, where 0 is the actually zero likelihood or no likelihood of something happening, and 1 was absolute likelihood that something was happening. So and let's say 0.5 in the middle, then we can say something is, over here, something is uh, uh, kind of moderately likely to happen. If something was like, let's say, 0.7 here, we can say something is, mildly likely, highly likely, mildly likely, or actually highly likely to happen. And if something was like, let's say 0.9 here, then we would say something is very likely to happen. The same thing with the negative spectrum. So this is how we express it. Although, like as I said, there are several ways that we can express probabilities. We can express probabilities in terms of fractions, which could be, let's say, in the case of the coin, could be 1 over 2, where 1 is the possibility of the event, 2 is the possibility of all of the events. We can also do it by fraction, which is 0.5, sorry, by percentage, which is 0.5, and 0.5 actually translates to 50%, so we can do percentage as well. Or we can also use proportion, which is 0.5. So um, we have a variety of options to express a probability in terms of in quantitative terms, but the most favorable type is proportion that the numerical proportion that goes from 0 to 1, where 0 is absolute zero likelihood and 1 is absolute highly likely. Absolute likelihood and 0 is zero likelihood. So again, even though we can express probabilities as percentages or fractions or percentiles or proportions, we can write them down using real numbers between, again, 0 and 1. So instead of using 20% or using 50% or one fifth, or instead of using 20% or one fifth, we prefer simply 0.2. All right, now let's just briefly talk about interpreting these probabilities values. Generally, the probability of an event is denoted by the word p. For example, in this case, would be p of a for one of the probabilities for, let's say, for the heads, or maybe b for the tail. So again, the probability of an event occurring is denoted by the letter P. P of A, as you can see in here, is equal to number of preferred outcomes. So there's a lot of terminologies used in the context of probabilities or solving for probabilities that you need to familiarize yourself with, because it helps you in understanding advanced probability methods. So P of A is equal to number of preferred outcomes over the total number of possible outcomes. So the preferred outcome is 1, and all the possible outcomes is 2. So we have head, which is one of the two all possible outcomes available, which is two sides. So one side divided by two sides. So that the word is called preferred outcome, and also the denominator is called all possible outcomes. So by preferred, I mean outcomes that we want to see happen. So a different term people use for such outcomes is favorable. So similarly, sample space is a term used to depict all possible outcomes. So moving forward, we shall use the respective terms interchangeably. So we will go through several other examples to ensure that they understand the notion well. For example, let's say event A is flipping the coin and getting heads. In this case, heads is our preferred outcome, assuming that the coin doesn't just somehow stay in the air indefinitely. There are only two possible outcomes once the coin lands on the ground. It's either heads or tails. So this means that our probability would be a half. So we write the following: P of getting A equals to 0.5, and then P of getting B is 0.5, where A is again heads and B is tails. So now imagine if we had a six dice, a die. So the word die, and we want to roll a 4. So in this case, once again we have a single preferred outcome, but this time we have a great number of total possibility outcomes. This time the total possibility outcomes is not 2; it's actually 6, which is because it's a die with 6 sides. So so when we again, we have a greater total number of possible outcomes. So therefore, the probability of this event would look as something as, for example, one. If we were to look at, for example, getting a 3 out of a die of 6 sides, it will be like this 1 over 6. And if we calculate, then it's going to give us a an outcome that will be different from 0.5. So again, the idea here, so far so good. The idea here is to make sure that you understand at least the idea behind probabilities, and how the quantification works. And this is it's a good start point for you, but I'm going to expand. And this is a demonstration to further analysis of probabilities and additional methods of probabilities, including dependent probabilities and probability distributions. And those will be helpful in getting profound knowledge of the subject. Until next time, thank you.